Welcome friends. In this video, I'm going to be talking about arithmetic operations with surds, and under this I'll be looking at addition and subtraction of surds. Many students find this aspect of surds challenging because of the fact that they have not fully understood algebra and how it works. So now let's try something. Let's say you have root 3 plus root 3. Okay, which is surd 3 plus surd 3. Okay, now if you look at these two, they have the same radicand. In right, is a radicand. Now by radicand, I mean they have the same number under the square root sign, 3 and 3. See, now this makes these two surds to be like surds, just as you have like terms in algebra, like terms. And you know, in algebra, you can add and subtract like terms. For example, you have 2x plus 8x. You can add these two because they are like terms. They have the same x. X is here. They have the same letter here, x, x. When you add these two, you get what, 10x. In the same vein, when you are talking about surd, if they have the same radicand, as the same number under the square root sign, you can add and subtract those surds. For example, root 3 plus root 3 is going to be what? So the way you add here is that you look at the coefficient. Though it's not written, the coefficient of root 3 here is 1, same as here. So when you add 1 plus 1, it gives you what? 2. So this is what? 2 root. Then you maintain the common surd that they have, which is surd 3. Okay, just as we have here now. X was maintained, then we just added the coefficient, giving us 10x. So let's look at another case. Let's say you have, okay, this is case 1. For case 2, you have 2 root 3 plus root 5. Now let me ask you, can you add these two? Of course, the answer is no. The reason for that is because if you check, the radicand here is 3, the radicand here is 5. They have different number under the square root. So we cannot add these two terms. And this is how you just leave this particular sort, okay? So let's try another case. Let's say you have 3 root 7 minus 2 root 7. This is easier, right? Subtraction. 3, 2, they have the same radicand, so we can easily subtract, like I told you before. So you do 3 minus 2, which is 1, and then you maintain the common surd that they have. So that's surd 7. You can decide not to write this 1 here. Okay, and the answer is what? Surd 7. I think we should try another case. Let's try another case. So 5 surd 6 minus surd 6. Look at this. What's the coefficient of surd 6 here? It is 1, right? Good. So you can just do 5 minus 1, which is what? 4. So that's 4 surd 6. So this is how you add and subtract surds. Now, we are going to be looking at some real examples under this topic. So look at this one, root 18 plus 2 surd 2. All right. Now, if you check, they don't have the same number under the square root sign, but we can break this root 18 down. Let's do that. So root 18, the way you break it down is that you look for two numbers. Now, don't use 6 times 3. 6 times 3 will give you 18, but 6 is not a perfect square. 3 is also not a perfect square. So the way you break this kind of numbers down is that you look for one number has to be a perfect square. So if you want to break this down, let's use 9 times 2. This is what is going to work here. What is the square root of 9? It is 3. And then you maintain the surd 2 that we have. So if you break root 18, it's going to give you 3 surd 2, then plus 2 surd 2. Now check, they have the same radicand, 2, 2. We can just add the coefficient. All right. Now if you want to do this, this becomes what? 5. 3 plus 2 is 5, then surd 2. Let's try another example. So what about root 12 plus root 48? Now we can just break the two of them down. Let's break 12 down. That will be 4 times 3. Okay, I think we should write it here. So this is what? 4 times 3. Now what about 48? Remember, we're trying to make sure that you have the same radicand. So what about 16? 48. It is what? 16 times 3. 16 is a perfect square. 3 is not. So we can use that because I know that we already have a common radicand, 3 and 3. So that's 16 times 3. Good. So what is the square root of 4? That's 2. So 2 root 3 plus, what about this? The square root of 16 is what? 4, then root 3. Look at this. They have the same radicand. We can just add the coefficient. What is 2 plus 4? That is 6. And then you maintain the common surd. So surd 3. So this right here is your answer. Let's look at another example. Okay, we have a mixture of subtraction and addition. Good. Look at this 8, 32, 18. I can break all of them down and they will have a radicand of 2. Yes, they will. So 8 can be broken down to what? 4 times 2. What about 32? 16 times 2. Notice 16 is a perfect square. Same here, 4 is a perfect square. Now what about 18? 9 times 2. So that is 9 times 2. Okay, it's time to simplify this. That is 3. I'm going to use dot for times. Dot is times. The square root of 4 is 2. So we have root 2. Then what about this? 2, then times. The square root of 16 is what? 4. Then root 2 plus the square root of 9 is what? 3. So that's 3 surd 2. Okay. So let's multiply. 3 times 2 is what? 6. Then 6 surd 2 minus 2 times 4 is 8. 8 surd 2 plus 3 surd 2. All right. Well, it's now time to add and subtract. You can decide to rearrange them with respect to their signs. I can do 6 surd 2 plus 3 surd 2 minus 8 surd 2. I think we should do that. So 6 surd 2 plus 3 surd 2 minus 8 surd 2. What's 6 surd 2 plus 3 surd 2? That's 9. 6 plus 3 is 9. So 9 surd 2 minus 8 surd 2. What is 9 minus 8? It is 1. So you can just write 1. Or you may not, you don't even have to write it. So I can just remove the 1 because it's the same thing. So your final answer here is surd 2. How about you try this question? Yes. And leave your answer in the comment section. If this video was helpful to you, kindly subscribe to this channel, like this video, share it to your friends and family, and I will see you in the next one. Take care.